Hello everyone, this is Ronnie Crow again. I'm going to be taking you through lab number 4 in the networks and infrastructure. We're going to be looking at address resolution protocol analysis. Hang tight while it loads. Okay, here we are. We are in this lab. You're going to access ARP requests and responses, and you expect it to create an asset list. Okay, the scenario is very straightforward here. It says this slide will illustrate the importance of ARP packets for students. It will demonstrate how ARP successfully links hardware addresses such as MAC addresses with logical assignments such as IP addresses. When we look at the 7 layers, we did talk about layer 1 and layer 2, which deals with the MAC addresses, and that's exactly what we're going to be looking at here. So if you haven't done this lab before, please, I do advise you to watch this video. Okay, let's move to the next page. So I'm going to read this through. So address resolution protocol, which is ARP, is one of the most important protocols to understand when conducting asset management. It's very important. ARP directly links data link layer addresses such as MAC addresses with network layer addresses such as IP addresses. Understanding how these two variables connect together provide first responders and IT admins the ability to rapidly address issues when and where they find them. Before attempting the performance-based labs, we recommend watching this lab walkthrough videos. Like I said, these videos are designed to help give you the best user experience and prepare you to achieve 100% on the labs. Knowing how to successfully complete the labs is key in passing the certificate exams, like I said. Okay, so basically the ARP simply connects. So the MAC address is on the hardware, while at the network layer, this MAC address needs an IP address in order to communicate with other IP addresses within the network interface. So, okay, so we're going to log into Kali here. Username, the password, which is just simply password but with a 0. Okay, here we're going to navigate. We're going to switch to the desktop directory. So we're going to open the terminal. Okay, we're going to do cd for change. So we're changing directory. Then we type desktop. So cd stands for change. So we're moving into the desktop. So we're going to lay in the key. So we're going to run Wireshark excessive. And if you look, Wireshark excessive backlog ARP is .pcapping. So this is already a file that's already been captured, and it's already on the desktop. So exactly what we're going to be running here. So we're going to go ahead and do this. So we're going to do Wireshark space excessive backslash ARPS dot p cap ng. Like I said, it's a captured file. I'm gonna put a space on there. Go ahead and put a space on there. Okay, then we're gonna hit enter. There you go. So we're running this Wireshark file. I'm gonna go down and says step 3. Notice that you do not need to filter for ARP as the entire PCAP is made of ARP packets already. It's because it's captured. However, you should become more familiar with the ARP filter. Type ARP in the filter. So if you were to filter says, hey, this captures everything, in normal circumstances when you run Wireshark will capture every traffic. In this case, you're required, it's already been filtered in ARP, but if you had multiple stuff and you want to filter something very particular, right, in this case, we've been asked to filter ARP. So we're going to go ahead and on the search bar on the filter, and we're just going to type ARP, and then we're going to press the enter key. So everything, you could see the protocol, address resolution protocol. It's going to pick up all traffics that are related to that. So okay, that's it. You can see that's it. You can go, you can see that. Okay, step 4 says remember that ARP functions in a request or reply method. Of course it does. One device asks to know another's IP address. That's how it happens, right? Says you have a router that has a MAC address, so it's connecting or it's trying to communicate with all the wireless devices in your house or IoT devices. Let's say your phone, for instance, right? So it goes through that process of request and response. So it's asking for something and then it says, hey, this is my IP address. What's your IP address? And it says, hey, this is who I am. Okay, if you look, you can see the who. Okay, so here we're required to filter for ARP requests with the filter arp.opcode. So we're going to go ahead on the filter bar. We're going to do the dot op code 1. Just simply for us to filter the ARP request. Okay, so notice that this presents you with only ARP request from the capture. You will also notice that every packet has a destination of broadcast. This is because the ARP request is sent to everyone on the network. Yep, remember we talked about hops and we talked about how they do communicate, right? They communicate by broadcasting. They'll just send it, and some of them are more intelligent than the others because they can broadcast based on an IP address to a specific destination IP address. So okay, so as you can see, right, the highlighted row in blue, right, it's an example. You can see all that stuff, Roku. So that's it. So you could see that's the source and that's the destination, means it broadcast, uses the address resolution protocol, and that's it. That's the time it took. Okay, step 5. ARP responses provide even more direct information about devices. Specifically, they announce that their IP address is at their MAC address. Okay, this makes asset identification even easier. Use the filter. Now we're going to change the 1 to 2, right, to present only. So we're checking on the responses now. So when you do that, when you enter that and do the 1, that will be to filter for request. When you change it to a 2, filter for responses. Yep, so it's gonna give us only the ARP responses. There you go. You can see the various devices. You can see like Belkin, Amazon, T, Slim Device, Chamber, Physical, Asus Tech, Roku. You could see. Okay, gonna go down to step 6. Wireshark allows the user to easily view which protocols are used overall in a PCAP. Yep. Clear your browser or clear your filter by clicking the X button and open the protocol hierarchy statistics by selecting statistics and protocol hierarchy. So we're going to go ahead and click the X to clear our filter. Then we're going to go ahead to the protocol statistics, hierarchy statistics, by selecting statistics. There we go, and protocol hierarchy. There you are. We're going to click on that. There you can see. So this is the protocol hierarchy. Starts with the frame, then Ethernet, then address resolution protocol. That's it. That's the protocol hierarchy. So we're going to go ahead and close this. And close Wireshark. Got into step 7. And return to the terminal. Here we're going to do the Control C to return to the terminal. It's going to kill Wireshark. Step 8 says now we're going to map the device on a network using address resolution protocol. So here we're going to create a file on the desktop named netmap.txt by executing touch netmap.txt. Okay, so what we're expected to do here is, so you're trying to do a broadcast, find out do an address resolution protocol to search devices on the network and connect their MAC addresses to their IP addresses. So now we're required to create a file, a text file, because as we do it, we're going to be logging into it. So, okay, so we're going to go ahead and type touch netmap.txt. Enter. We created that file already. You can see that's it on the desktop. netmap.txt. Okay, we're gonna come back. So in the terminal, we are going to, so first let's check our own networking information by viewing our network interface card using our IP command with the address option, which is short for address. So in our terminal, we're going to go ahead and execute IP address. So we're trying to check whatever our network information is. So we're going to start by IP space address. That's how we do it in Kali Linux. And you hit enter. So what we're going to see here, which is very important, is our Ethernet 0 interface, which tells us that's a local area network. So if you can look at this, right, take a look, you'll be able to figure out that our IPv4 address is 192.168.1, and meaning we are on the same network, this, because that's the IP range. Okay, so we can also see our MAC address next to a link or ether, and that's our MAC address. I'll maximize this so you can see. So that's it. Yep. So this is our MAC address. And that is the IPv4 address, which falls within this range. Okay, step 11 says double click the netmap.txt file and record our A through IP and MAC addresses. So I'm going to go ahead and double click that to open up on the site. So I'm going to record a Kali IP address which is 192.168.1.8, and on the side I'm just gonna include the MAC address. Remember we went through this I think in chapter 1 when we talked about layers, the OSI model. 5D clone 01 clone 80 clone 1. Okay, I'm not going to close it. I'm going to leave it open. Step 12 says to view our ARP table in Linux, we can use the ipna command, which just says neighbor, short for IP neighbor. When a device on the network receives an ARP response, it records that MAC and IP addresses in its ARP cache. So we're going to go ahead and check the ARP table by executing ipna. Remember we talked about that ARP table. So we're going to go ahead and type ipna and press enter. So what we found, so from the output we can see that both an IPv4 and IPv6 addresses map into the same MAC address. This is our gateway, which has both an IPv4 and an IPv6 address. So I'm going to go ahead and record the IPv4 address and MAC address in this net map. So we're going to go down, we're going to add to a file, so we're going to call that the gateway, right? Which is 192.168.1.1. Definitely is the gateway. And we're going to go ahead. I'm going to close up here with step 11. Step 12. To view our ARP table in Linux, we can use the ipna command, short for IP neighbor. When a device on the network receives an ARP response, it records the MAC and IP address in its ARP cache. So let's check the ARP table by executing ipna. IP there you go. So I'm going to check that up. We check the IP neighbor addresses in the ARP table, and we notice that IPv4 and IPv6 addresses are mapped into the same MAC address. You can see that. See, those are the MAC addresses, the same MAC addresses. So you have the IPv4 that is mapped to the same MAC address, and you have the same you have an IPv6 address that's mapped to the same MAC address. So I'm gonna go ahead and record it down, add it onto this table. Go. And that's the gateway. One 192.168.1.1. That's the gateway. MAC address 15. 5D 01 colon 80 colon 00. Let me double check. Okay, there you go. Step 14 of the process. Depending on the device's settings, they may not broadcast the ARP information over the network. Instead, you may have to initiate communications first. There is an Ubuntu machine at 192.168.1.50, but it hasn't populated in our ARP table. So we're going to have to ping that. We're going to have to ping that Ubuntu machine to have it respond. So we're going to go ahead on step 14. We're going to go back to the command line. We're going to type ping run safe account. I want to send 5 packages, 192.168.1.50. So please practice ping, because every time you change the network IP address, or every time you make changes, or when you're required to broadcast and verify if a machine is live or it's connected, that's what you need to do. You need to ping ICMP packages. So I'm going to do the enter key. I'm sending 5 packages. All 5 packets were transmitted, 5 received, 0 packet lost. Okay, so on step 15, we did successfully communicate with the device. We should be able to have an update in the ARP table. So we're going to go back again and relaunch the IPNA. You can just use an arrow key. If you've already entered a command before, you can use an arrow key to bring it back, or you could just type it manually, IPNA, and you do the enter. So now you can see in the previous command that we logged in, we did not have this one. But after we did ping that machine and we rerun the IPNA, we're able to. So great, our ARP table has been updated. So we're going to go ahead and record that in our text file. We're going to call it an Ubuntu machine. We're going to go ahead and enter the IP address 192.168.1.50, and we're going to enter the MAC address. So what we're going to do here, so what we did here is we paired the IP addresses to the MAC addresses. Okay, so we create that table. We're going to go ahead and save the file by clicking File, Save, and then close the text file. So we're going to go ahead and click on that, and we're going to go ahead and save. Now we've saved the changes. Go ahead and click on the X and close the file, and we can close the terminal. So basically, in a nutshell, this is how you run analysis for an address resolution protocol, right? That's how you do. You can start by the machine by doing the IP address to check the network configuration for the machine, the IP address of that machine in question, and the MAC address of that machine. And it can also give you the IP range, right? Like we said, here we have the A2, give you the IP range. So keep that in mind. We've come to the end of this lab. I'm going to go ahead and submit it for a grading.